Hello, Mr. Sutton here, bringing you the AB Calculus 311 Extra Practice Number 4 solutions on derivatives of logarithmic functions. To take the derivative on this one, there's actually quite a bit going on here. One thing we're going to do to make our lives a tiny bit easier is we're going to pop out this square root as an exponent of 1/2. It's actually going to be a coefficient when we pop it out. So this is going to be 1/2 ln of all that stuff inside that fraction. And now we're going to actually take the derivative. So we're going to have 1/2 times, and now let's see here, we have ln of something. Well, the derivative of ln of something is going to be the reciprocal of something, or 1 over something. Rather than writing 1 over all this craziness, I'm just going to flip it upside down because that's really the same thing. So I'm going to have 1/2 times all of this upside down, 5x to the 4th minus 1 over 6x to the 8th. And now I'm going to have to multiply by the derivative of this original fraction. For that, I'm going to need the quotient rule. So setting up my box and ribbon, I've got 6x to the 8th, 5x to the 4th minus 1, and their derivatives, which are 48x to the 7th and 20x cubed. All right, using the ribbon to put this back together, we've got 48x to the 7th times parentheses 5x to the 4th minus 1 minus 6x to the 8th times 20x cubed. I'm not going to simplify any of this. And then we have to divide by a v squared there. It's u prime v minus uv prime over v squared. So that's this 5x to the 4th minus 1 quantity squared. For this problem, taking the derivative of this composition of functions, I've got a few chain rules going on. The outermost function is the ln of something. Derivative of that is 1 over the something, 1 over ln of 3x to the 7th in this case. Next, I have to take the derivative of ln of 3x to the 7th. That's another ln of something kind of situation. So we have 1 over 3x to the 7th for that derivative. And then finally, we have to take the derivative of 3x to the 7th itself, which is going to be 21x to the 6th. And if I wanted to, I could simplify this thing. There's no need, but if I did, we would have, let's see, 21 over 3 is going to be 7, and we can reduce this to just x in the denominator. So 7 over x ln of 3x to the 7th might be important if you had a multiple choice question you had to match an answer choice with. For this problem, one thing I notice when I'm trying to take the derivative is that I have a variable in both the base and the exponent. So for this, I will use logarithmic differentiation. So I'm going to take the ln of both sides. That's going to give me ln of y equals, and now this x squared exponent pops out. We have x squared times the ln of x plus 1. And at this point, let me implicitly differentiate. So on the left side, derivative of ln of y, that's going to be 1 over y. But because this is an inner function, y is an inner function of x, we have to multiply by the derivative of y, which we're just going to call dy over dx. Next, on the right side, we need the product rule. So we have x squared and ln of x plus 1, whose derivatives are, this is going to be 2x, and this is just going to be 1 over x plus 1. So multiplying that out, we have 2x ln of x plus 1. And then this will be x plus 2, or x squared over x plus 1, if we just merge that into one big fraction. To isolate dy over dx, now I multiply both sides by y. So that puts everything on the right side in one big parentheses with a y outside. And since my answer has to be in terms of only x, that means I'm going to replace y with the stuff that y equals in the beginning, the x plus 1 raised to the x squared power. On this one, we're trying to figure out the derivative of 7x to the x to the 10th. Since I have variables in both the base and the exponent, I need logarithmic differentiation. So I'll start by taking the ln of both sides, and I'll think of this as a y over here. So I've got ln of y equals, and now this x to the 10th pops out in front. So we have x to the 10th times the ln of 7x. Implicitly differentiating everything, I've got 1 over y times dy over dx, because y is an inner function of x, equals, now I need the product rule, so box and ribbon time. We have x to the 10th and ln of 7x, and then our derivatives, we've got 10x to the 9th, and this is going to be 1 over 7x times 7, which I could reduce to 1 over x if I wanted to. Now let's multiply it all out using the ribbon. So we've got 10x to the 9th ln of 7x, plus, going the other way here, this is going to be x to the 10th over x. which if I wanted to, I could reduce to x to the 9th. And now to isolate dy over dx, we multiply both sides by y. So all of the stuff on the right here goes in a big parentheses with a y outside. And then finally, our answer has to be in terms of x only. Why? Because they said so. So we're going to replace this y with 7x to the x to the 10th, like so. All right, there we are. For this problem, I'm trying to take the derivative of log base 4 of this stuff. So this is a chain rule. Our outer function is log base 4 of something. Derivative of that is going to be 1 over the something times the ln of 4. So 1 over all this stuff in a parentheses with an ln of 4 thrown in. Now I have to multiply by the derivative of the something of x cubed minus 3x. That's going to be 3x squared minus 3, and I'll just stick it up there. And that's it. On this one, I'm trying to take the derivative of 1 over log base 2 of x. So it'll probably be easier if I rewrite this with a negative exponent. I'm going to call this log base 2 of x, all of that to the negative 1. And now we see that this is actually a chain rule. We have our outer function is something to the negative 1 power. So the derivative of that outer function, we're going to have negative 1 times the something to the negative 2. And then we have to multiply by the derivative of the something, the log base 2 of x, which is just 1 over x ln of 2. For this one, I noticed that I have a variable in the base and the exponent. So you know what time it is. It's logarithmic differentiation time. We'll start by taking the ln of both sides to get this x variable stuff out of the exponent land. So I've got ln of y on the left side. On the right side, 6x pops out to join the mere mortals, and then we have ln of sine of x hanging out as well. So diffing, implicitly differentiating from left to right, we've got 1 over y dy of dx on the left side. And on the right side, we need a product rule. So I have factors of 6x and ln of sine of x. So those derivatives are going to be 6, and this is going to be 1 over sine of x times the derivative of sine, which is cosine. And of course, I mean, why not just turn that into cotan and have one less fraction floating around here? So using the ribbon to put it all together, we've got 6 ln of sine of x plus 6x cotan of x. Now to isolate dy over dx, I need to multiply y by both sides. So all this stuff on the right, I'm putting it in a parentheses with a y outside. But now they said they wanted this in terms of x. So to make them happy, we're going to replace y with the stuff that y equals up here, the sine of x to the 6x. For this problem, I'm trying to take the derivative of ln of all this stuff to make my life a little bit easier, because I'm looking at a massive chain rule with a quotient rule built into it. I'm going to pop this exponent of 6 out in front. So this is really just 6 ln of that big fraction. Still not great, but we'll deal with it. So at this point, I'm going to take my derivative. I've got 6 times ln of something as the outer function. So that's going to be 6 times 1 over the something, which is just the reciprocal of the something. So I can call this 6 times 3x to the 5th plus 5 over 3x to the 3rd. So this is really the same as 1 over that. I just flipped it, took the reciprocal. Now I have to take the derivative of this inner function, although it's actually this inner function here, so be careful. This is the thing you're taking the derivative of. We actually flipped it to get this. So for that, I'm going to need the quotient rule. Here's my box and ribbon to help me with that. I've got my numerator, the original numerator of 3x cubed, and the original denominator of 3x to the 5th plus 5, and the derivatives of these, which are 9x squared and 15x to the 4th. All right, that's the 4th power. That's better. All right, so let's multiply this out with the ribbon. So my general format, I've got u prime v minus uv prime over v squared. So u prime v, that's going to be 9x squared times parentheses 3x to the 5th plus 5. So we're going this way. Minus uv prime, so that's 3x cubed times 15x to the 4th, and we're subtracting all that, over v squared, so that's this stuff squared. And there it is. For this one, we want the derivative of ln of 2 minus cosine of x. This is a small chain rule. We have as the outer function ln of something Derivative of that is 1 over the something, so 1 over 2 minus cosine of x. And now we need the derivative of 2 minus cosine x itself. The 2 goes away, that's just a constant, so derivative of that is 0. But the negative cosine of x, that's going to become a positive sine of x. And we can't do any better than that, so we're calling it a day. On this problem, I'm trying to take the derivative of ln of 4x to the 10th. So this is a chain rule. We have as the outer function ln of something. Derivative of that is going to be 1 over the something, so 1 over 4x to the 10th, times, now we have to multiply by the derivative of the inner function. 4x 10 derivative is going to be 40x to the 9th. And there's no need, but if you wanted to simplify this, we could call this 10 over x. On this problem, I want the derivative of log base 2 of x squared. Just to make my life a tiny bit easier, I'm going to pop that 2 out in front, and now I'm just doing 2 times derivative of log base 2 of x. So that's going to be 2 over x ln of 2. On this one, I'm given this g of x function, which is 2 times ln of x plus 1. We're told f is differentiable, and we want to know what's equivalent to the derivative of f of g of x. Okay, well, if I want to take the derivative of f of g, I need the chain rule. So I'm going to have f prime of whatever the g of x function is. So in this case, f prime of all this stuff, 2 ln of x plus 1. But now I have to multiply by the derivative of the inner function. So the derivative of g. And that's going to just be, using my ln rule here, that's just going to be 2 over x plus 1. So looking at answer choices, it looks like, let's see here, we've got a 2, we've got an f prime of all that stuff. That looks like it's going to be choice D. On this problem, I'm trying to take the fourth derivative of 2 ln of x. So let's just start with the first derivative and keep taking derivatives. First derivative is going to be 2 over x, or 2x to the negative 1 is probably easier for what I have to do on this problem. And now using the power rule, second derivative, that's going to be negative 2x to the negative 2. Third derivative, now we've got 4x to the negative third. And for the fourth derivative, negative 3 times 4 gives us negative 12x to the negative fourth. So that's really negative 12 over x to the fourth, which is going to be choice B.